Look up at the moon for a moment and notice how calm it feels, how familiar, how close it seems hanging quietly in the night sky, because that illusion is exactly where the story begins. What you are looking at is not a nearby destination, not a poetic companion to Earth, but one of the most hostile targets humanity ever dared to aim for. Long before anyone celebrated success, the idea of reaching it sounded less like science and more like madness, a plan built on equations instead of instincts, faith in physics instead of comfort, and the willingness to accept that failure would not come with a second chance. This is not a story about flags or footprints or nostalgia. It is a story about why everything about this mission should have collapsed under its own weight. Why distance alone should have defeated us. Why power should have destroyed us. Why our bodies should have failed us. Why our machines were never meant to handle the task. And why the human mind should have cracked under the pressure. And yet, against all expectations, it worked. To understand how, you first have to understand why it was never supposed to. Stay with this until the end, because the real miracle of the moon landing is not that it happened, but that reason itself survived the journey and came back to tell the story. When people imagine the moon, they imagine something close, familiar, almost reachable, a glowing object hanging quietly in the night sky. But distance in space is not measured by how it looks. It is measured by velocity, angles, margins of error, and time spent moving through nothing. And in that sense, the moon exists at a scale that is deeply unnatural to the human mind. The average distance between Earth and the moon is so vast that if you tried to drive it at highway speed, it would take months without stopping. Yet the spacecraft had to reach it in days, meaning it had to travel faster than any human intuition could comfortably grasp. Space offers no reference points, no air resistance, and no friction to correct mistakes. So once you are moving, you are committed to that path unless you deliberately change it with carefully calculated bursts of energy. A tiny error at launch does not result in being a little off course. It results in missing the moon by thousands of kilometers, drifting into darkness with no natural way to turn back. Even aiming at the moon is deceptive because the moon is not stationary. Earth is rotating. Both bodies are moving through space, and the spacecraft must intercept a future position that only exists mathematically. This requires trusting equations over instinct, numbers over sight, predictions over certainty, and doing all of it with technology that could not visualize space the way we do today. Humans evolved to throw stones, not to aim for a moving target hundreds of thousands of kilometers away while standing on a spinning planet hurtling through space. And yet the mission demanded absolute confidence that invisible paths calculated on paper would translate into reality, a leap of faith grounded entirely in physics and disciplined thinking rather than comfort or familiarity. Escaping Earth is not a gentle process. It is an act of controlled violence against gravity itself, and the only way to do it is by riding a machine that behaves less like a vehicle and more like a barely contained natural disaster. To leave the planet, a rocket must accelerate to speeds so extreme that the human body experiences forces it was never designed to tolerate for long, all while the structure holding everything together is being shaken, heated, and stressed to its limits. The fuel does not burn calmly, it detonates in a continuous chain of explosions directed downward, producing enough energy in minutes to rival the output of entire power plants. And that energy must be perfectly channeled or the mission ends instantly. Every bolt, wire, valve, and weld must perform flawlessly while being assaulted by vibration, pressure, and sound powerful enough to tear metal apart. The idea that such a machine can lift off smoothly is already improbable. But the truly impossible part is precision, because brute force alone is useless without control. The rocket must not only go up, but it must go up at the exact right angle, at the exact right rate, for the exact right duration. Because too little energy means falling back to Earth, and too much means overshooting into a trajectory that can never be corrected. Inside this controlled chaos, humans are strapped into a capsule at the top, feeling every tremor, trusting that mathematics, engineering discipline, and countless unseen safeguards will hold together while everything below them tries to fly apart. There is no pause button during ascent, no way to stop and reassess, because once ignition begins, the sequence unfolds faster than human reaction time. What makes this feel impossible is not just the power involved, but the fact that such violence can be shaped into obedience, that raw energy can be disciplined into a narrow path through the sky, lifting fragile human lives away from a planet that has held them captive since birth. The human body is a masterpiece of adaptation, but it is adapted for forests, plains, gravity, air, and protection, not for an environment where even survival is temporary and conditional. Every system inside us assumes Earth is always there, pulling blood downward, stabilizing balance, filtering radiation, and providing a constant sensory reference point. And the moment you remove those assumptions, the body begins to unravel in subtle but dangerous ways. In microgravity, muscles lose purpose and weaken. Bones release calcium and slowly hollow out, and fluids shift upward into the head, distorting vision and increasing pressure inside the skull, while the inner ear loses its anchor, confusing the brain about up and down. Space is also filled with invisible threats that cannot be felt until damage is already done, like radiation that passes through flesh and DNA alike, increasing long-term risks in ways that were not fully understood at the time. There is no natural protection, only thin layers of metal standing between a human being and a vacuum that would boil bodily fluids and extinguish life in seconds. Even sleep becomes unnatural, because the body no longer knows when to rest, when to wake, or how to orient itself in silence and darkness. Beyond the physical danger lies the psychological strain of confinement, isolation, and the awareness that Earth is no longer beneath your feet, but far behind you, shrinking into something distant and unreachable. Every sound becomes amplified, every mistake feels heavier, and every decision carries the weight of survival. The idea that fragile biological organisms could function, think clearly, operate complex machines, computer glitch at the wrong moment could strand the spacecraft in orbit, send it past the moon, or trap it on a return path that never intersected Earth. Unlike machines on the ground, broken systems could not be repaired with tools or replacement parts, and even small errors compounded over time, turning manageable problems into fatal ones. The mission timeline was unforgiving because fuel margins were thin, windows for course corrections were narrow, and every action depended on the success of the previous one, forming a chain where the weakest link decided everything. What makes this feel impossible is the psychological reality of knowing that survival was not guaranteed by skill alone, but by an uninterrupted sequence of correct outcomes in an environment that does not allow improvisation, mercy, or second chances, where success meant threading humanity through a corridor so narrow that failure was statistically easier than survival. When people look back at the moon landing through the lens of modern technology, it becomes difficult to grasp how limited the tools really were. Because today we are surrounded by devices that calculate, correct, and predict automatically, while the mission relied on systems that were astonishingly simple by comparison. The onboard computers had less processing power than a basic digital watch. No graphical displays, no memory for complex simulations, and no ability to rethink a plan once it was in motion. They followed instructions line by line, executing pre-written commands without understanding context, meaning that human judgment had to fill the gaps where software could not adapt. Navigation was done using stars, angles, and timing, not satellites or real-time maps, and much of the work depended on analog instruments, switches, and dials that required constant attention and interpretation. Engineers on the ground calculated trajectories using slide rules and mainframes that filled entire rooms, translating abstract mathematics into handwritten procedures that astronauts memorized and rehearsed. There was no safety net of automation to quietly correct mistakes in the background, so every adjustment had to be intentional and precise. Even communication was constrained, with limited bandwidth and simple signals carrying information that had to be decoded mentally rather than visually. What feels impossible is not that this technology existed, but that it was trusted with lives in an environment where even a tiny error could have irreversible consequences. Success depended less on raw computing power and more on clarity of thought, discipline, and an almost obsessive respect for procedure, turning the mission into a collaboration between fragile machines and highly trained minds that compensated for technological limits through preparation, focus, and restraint beyond the machinery and mathematics was a challenge that could not be tested in laboratories or solved with equations, because the human mind reacts differently when it realizes there is no immediate way home. The astronauts were not just traveling far from Earth, they were separating themselves from every psychological anchor that gives a person a sense of safety, routine, and scale. Outside the window was not a landscape or a horizon, but an endless blackness that offered no clues about direction or distance. And inside the cabin was silence broken only by mechanical sounds that suddenly carried enormous meaning. Every unfamiliar noise triggered awareness. Every vibration demanded interpretation, because the line between normal operation and disaster was thin. Time itself began to feel distorted, as days blended together without sunrise or sunset, forcing the mind to operate without the natural rhythms it relies on for stability. The knowledge that a single mistake could not be corrected by outside help created a constant background pressure that never fully faded, even during moments of calm. Isolation magnified responsibility, because each decision was not only technical but existential, carrying the weight of personal survival and historical consequence at the same time. The moon itself represented uncertainty, since no human had ever stood there before, and the surface was known only through distant observation and educated guesswork. Landing on it required trusting that the unknown would behave according to predictions, while remaining prepared to adapt instantly if it did not. What makes this aspect feel impossible is the expectation that human beings could remain composed, analytical, and precise, while fully aware that they were operating at the edge of existence, separated from Earth by vast emptiness, guided by discipline rather than comfort, and driven by a calm focus strong enough to silence fear without eliminating it. When you step back and look at the moon landing as a whole, what becomes clear is not how easy it was to explain afterward, but how unreasonable it was to attempt in the first place. Humanity aimed itself at a moving object across an ocean of nothing, road-controlled explosions powerful enough to escape a planet, placed fragile bodies into an environment that actively resists life, trusted machines weaker than modern toys, accepted that there would be no rescue and no second attempt, and carried the psychological weight of knowing that one mistake would not be forgiven by nature. By every ordinary standard, this should not have worked, and yet it did, not because the universe was kind, but because discipline, preparation, and respect for reality were stronger than fear. The achievement was not a triumph over space, but a moment where human reasoning aligned so precisely with the laws of physics that the impossible briefly became inevitable. It stands as a reminder that progress is not made by comfort or certainty, but by understanding limits so deeply that you can move right up to their edge without crossing into chaos, and in doing so expand what the future believes is possible. I wish you good luck on your journey ahead, whatever impossible goal you are aiming toward, and thank you sincerely for listening, for staying curious, and for being part of a story that reminds us how far disciplined thought and courage can carry us.